Why is feather a poor conductor of heat compared to metal? Thermal conductivity is a value that indicates how effectively heat is transferred within a material and is measured in units of mK. Materials with high thermal conductivity transfer heat well, while those with low thermal conductivity do not. Metals are known for their very high thermal conductivity. For example, copper has a thermal conductivity of approximately 400 mK, which is about 15,000 times higher than that of air, 0.26 mK. This is because the atoms in metals are densely packed, allowing electrons to move freely between them, playing a crucial role in heat conduction. Feathers, on the other hand, have very low thermal conductivity. The thermal conductivity of feathers is around 0.02 mK, similar to that of air. This is because feathers are filled with gas, just like air. Gases have much lower thermal conductivity compared to solids or liquids. Additionally, feathers are effectively separated by air pockets, making it difficult for heat to transfer from one place to another. Therefore, the reasons for feathers having a lower thermal conductivity compared to metals are as follows. Feathers are filled with gas, like air, and gases have very low thermal conductivity compared to solids. Feathers are effectively separated by air pockets, making heat transfer from one location to another challenging. Due to these characteristics, feathers play a vital role in maintaining the body temperature of birds and are also used as insulation materials. Metals typically have very high thermal conductivity. For example, copper has a thermal conductivity of about 400 mK, and iron has a thermal conductivity of approximately 80 mK. In contrast, feathers have very low thermal conductivity, usually in the range of 0.02 to 0.05 mK. There are two primary reasons why feathers have lower thermal conductivity compared to metals. Firstly, feathers are primarily composed of proteins, which have much lower thermal conductivity compared to metals. Secondly, feathers contain a significant amount of air. Since air has very low thermal conductivity, the presence of air within feathers contributes to their low thermal conductivity. The low thermal conductivity of feathers serves to help birds maintain their body temperature in cold environments. Birds wrap themselves with feathers to prevent the escape of internal heat to the external environment. Specifically, the proteins in feathers have fewer free electrons required for heat conduction compared to metals. Additionally, the air contained within feathers has weaker atomic bonds, which are necessary for heat conduction. Therefore, feathers have lower thermal conductivity than metals. The thermal conductivity of feathers can vary depending on factors such as the type of feathers, their structure, and their condition. For instance, down feathers have lower thermal conductivity than flight feathers because they contain more air. Additionally, when feathers become wet, their thermal conductivity increases because water has higher thermal conductivity compared to air. Metals are materials known for their high electrical and thermal conductivity. This is because the atomic structure of metals is densely packed, and there are strong bonds between atoms. As a result, heat can be rapidly transferred within metals through the movement of electrons. On the other hand, feathers have such low thermal conductivity that they can be used as insulators. This is due to the fact that feathers are filled with gas, similar to air. Air has significantly lower thermal conductivity compared to metals, so within feathers, heat is transferred through the movement of air. The movement of air is much slower than the movement of electrons within metals, leading to lower thermal conductivity in feathers. Furthermore, feathers have a structure where the individual feather filaments are intertwined. This structural feature hinders the flow of air within feathers, further reducing their thermal conductivity. Therefore, the reasons for feathers having lower thermal conductivity compared to metals can be summarized as follows. Feathers are filled with gas, like air. Feather filaments are intertwined in their structure. These characteristics enable feathers to help birds maintain their body temperature even in cold weather, and they are also used as insulating materials.